All right, guys, time to do, let's see, lines cut by a transversal. I'm gonna go ahead and share my screen with you. Let's see, we're right here. It should be sharing right there. I'm on the warm-up, but what I gotta do is I gotta get my guided notes. So let's pull those up. I gotta download those. There they are right there. It's in my desktop, in my guided notes folder, so that's gonna be fine. And let's see, so I can close this out. Need a new one. Pulling it from my computer in my guided notes. Lines cut by a transversal. And while this pulls up, I'm gonna go ahead and close these and hit the warm up and let's get started.
Welcome. Take a look here at the picture we have in front of us. We are looking at a parking lot. In this parking lot, we have several parallel lines that are all being intersected by a transversal. And that creates multiple parking spaces for drivers to park at angles. Now, these angles that are formed are important to us. And that's what we're going to be taking a look at in this lesson. We're going to be answering the question, what angle relationships are formed when parallel lines are cut by a transversal? So let's check it out.
We got new toys, guys. I'm over here trying to work with this, trying to figure out how to use this correctly. Let me just get a little bit extra room up here so that way I can situate myself a little better here. I got everything in front of me, so we just got to go ahead and get these right. Okay, so there's our question there, which is, let me go ahead and type in my question real quick, which is, what angles what angle that up? What lines are cut when what lines are formed when parallel lines are cut by a transversal? Okay, so we're going to learn about that.
Before we dive into this lesson, I want to take a look at our lesson goals. We're going to first classify angle pairs when lines are cut by a transversal, and then prove angle relationships when parallel lines are cut by a transversal. That'll allow us to solve for unknown angle measures when parallel lines are cut by a transversal. Now, you'll notice I keep using that word transversal, and that's because it's one of our words we need to know. So let's take a look at all of them. We have analyze and justify, which are in green because you're going to see them in other courses, not just math. We also have transformation and that word transversal. Now, these are in purple.
Okay, so analyze. Analyze means to examine or study. Okay. Justify. We have to defend or show to be correct. So we're justifying it, right? Transformation. Transformation is going to be an operation figure that may change. Okay, so remember, transformation is an operation on a figure that may be changed. So that's going to be D. And a transversal is a line that intersects two or more coplanar lines at different points. Okay, so that's just basically a line that will cut through. So let's go ahead and keep on going.
Because they are more key to this lesson. Now, I'd like you to go ahead and get the definitions, which you can find in the glossary at any time in this lesson.
I just gave you them
down in your e-notes, so you can reference them as we talk about them in the lesson, so you know what's going on. Now, I want to warm up, and we're going to warm up by taking a look at lines cut by a transversal. What is a transversal? Well, a transversal is a line that intersects two or more coplanar lines at different points. Here in this diagram, we have lines S and Q, and we can see that S and Q are cut by transversal R. And notice when that happens, we end up getting two groupings of angles. I have angles 1 through 4, as well as angles 5 through 8. And when that happens, we can actually identify special types of angles with names. So let's start with interior angles. Now, your interior angles are considered your angles in between lines. So if I look in between lines S and Q, notice that I have angles 3, 4, 5, and 6. Those are interior angles, where our exterior angles are, you guessed it, outside the lines. So if we take a look at our diagram here, we can see angles 1, 2, 7, and 8 would be considered exterior angles.
Okay.
Now, vertical angles, those are angles which are opposite angles formed by two intersecting lines, and they're also congruent to each other. Here in our diagram, we see angles 2 and angles 3 are vertical angles, and not only, as I said, they're opposite, but they're congruent to each other, so I'm going to show that congruency sign. In addition to angles 2 and 3, we also see 1 and 4 are vertical angles, 6 and 7, as well as 5 and 8. Let's move on to corresponding angles. Now, corresponding angles I find interesting because of their relative location. Take a look at the first grouping, angles 1 through 4, formed by R intersecting S. And I notice that 2 is in the upper right corner of that grouping. But if I move to the second grouping, where R intersects Q, notice how 6 is in the upper right corner. So we classify angles 2 and 6 as corresponding angles because in the same relative position.
But they are not
Other
congruent.
corresponding angles, well, that would be 4 and 8, 3 and 7, as well as 1 and 5.
They're not congruent, though.
Alternate interior and alternate exterior. Now, your alternate interior, well, we know they're interior angles already because we learned that before, but alternate tells us that they're on opposite or alternate sides of the transversal, as well as different
2 and
groupings.
7?
So we see angles 3 and 6 would be considered alternate interior angles.
Interior, sorry.
As well as angles 4
and 5.
5.
Those are alternate
So if I
interior.
move over to alternate exterior
These are-
angles, well, then I can see 1 is on the left side of the transversal, and in the different grouping, 8 is on the right side of the transversal. 2 and 7 would also be considered as alternate exterior angles. Finally, we have same side interior angles. And same side interior angles, which are also called consecutive interior angles, those are simply interior angles on the same side. So you can see 3 and 5 are on the same side and interior, as well as 4 and 6. Now I want you to use these classifications in order to be able to answer some questions about angle relationships on your own.
Determine which angle relationships are correct.
Lines M and N are cut by transversal L. Which angle relationships are correct? Check all that apply. 1 and 8 are alternate exterior angles. Alternate exterior angles are angles on the opposite sides of the transversal. 1 and 8 are exterior, alternate exterior, so that is true. 4 and 6 are same side interior. 4 and 6 are same side on the inside of this transversal. They're both on the right side of the transversal. That is correct. 5 and 7 are vertical angles. 5 and 7 vertical angles. Well, let's take a look at what vertical angles are. Those are congruent angles, and it's 2 and 3. 2 and 3, so those are opposite of each other. 5 and 8 would be, 6 and 7 would be. This one is not correct. Angle 2 and angle 8 are corresponding angles. Okay, so let's look. Corresponding angles have the same relative position as 2 and 6. 2 and 6, so they got to be in the same spot. 1 and 5, 3 and 7, 4 and 8. This one is 2 and 8. 2 and 8, that is not true. Okay, that is not true. 3 and 6 are alternate interior angles. 3 and 6, alternate interior angles. Interior angles on opposite sides of the transversal. 3 and 6 are opposite. 3 and 6 are opposite. This is also true.
These types of angle relationships will be explored more in the lesson.
Let's go on to the next activity.
We're working to answer the question, what angle relationships are formed when parallel lines are cut
We already
by a
have that.
transversal? Now, you identified types of angles that are formed when you have two lines cut by a transversal. Next, we're going to examine and prove the relationships of angles that are formed when parallel lines, like A and B that I have here, are cut by a transversal. Let's take a look at the relationships between angle pairs. Now, when parallel lines are cut by a transversal, the angle pairs have special relationships. Here we see in the diagram, I have two lines cut by a transversal, which means the classification of these angles, like I see here on the left, those are still the same. But in this case, we're talking about parallel lines. Notice the arrows on the lines. I know they're parallel because they're marked with those arrows.
They got to be marked.
I shouldn't make the assumption that they are parallel. I should always trust on what's given to me as information. Let's talk about these corresponding angles first. If I take corresponding angles of two lines that are parallel cut by a transversal, then the corresponding angles, such as angle 2 and angle 6, those would be congruent to each other. Alternate interior angles. Now remember, corresponding angles, those were in the same relative location, but alternate interior angles, those are interior angles on opposite sides of the transversal, but in the different
4 and
angle
5.
groupings formed by the two intersecting
3 and
lines.
6.
Those alternate interior angles, such as angle 3 and angle 6, those would be considered congruent as well.
4 and 5 also.
Lines cut by a transversal. So if I was referring to alternate exterior angles, the same idea. Take angle 2 and angle 7, for example.
1 and 8.
These two angles would also be considered congruent. Now, if I move on to same side interior angles, we know those are interior angles on the same side, also called consecutive interior angles. Now, you might think that these are congruent as well, but that's not the case because it's not based on congruency. Instead, if I looked at angle 3 and angle 5, I would be able to state that their measures are supplementary. So they're going to add up to 180 degrees, just as angle 4
these
and angle
two,
6 would be
these
supplementary
two,
as well.
these two.
So what I want to do now is I want
Not
to
these two, though.
examine the proofs of the relationships of the measures of these angles. Let's start with the corresponding angles theorem. Now, if a transversal intersects two parallel lines, then the resulting corresponding angles are congruent. So looking at this diagram, I see A and B are parallel. Therefore, if they're cut by transversal C, angle 1 would have to be congruent to angle 5. Angle 2 would have to be congruent to angle 6. Angle 3 would have to be congruent to angle 7. And angle 4 would be congruent to angle 8. That's a very useful theorem. So let's go ahead and prove it.
Pretty
I'm going
ugly.
to prove this using transformations. Recall that a transformation is an operation on a figure that may cause it to change its orientation, size, or its location in the plane. Now, a translation, that's a type of transformation, but it preserves, and angle 4
3 and
would be
7.
congruent to angle 8. That's a very useful theorem.
4
So let's
and
go ahead
8.
and prove it. Now, I'm going to prove this using transformations. Recall that a transformation is an operation on a figure that may cause it to change its orientation, its size, or its location in the plane. Now, a translation, that's a type of transformation, but it preserves size and shape of the orientation as well of a figure. That's actually really useful information to us because looking over here at this diagram, we can see an intersection of line R and line Q and the four angles that are created. Now imagine I take line Q and I translate it down. So I'm going to slide it down line R, creating a parallel line. I'm going to call that line S. Now, when this happens, I'm going to end up creating four new angles at the intersection of line R and line S. So let's go ahead and write those in. I have angle 5, angle 6, angle 7, and angle 8. Now, because translation preserves shape and size, and it also preserves angle measures, then we can state that the angles located in the same place but at different intersections are in the same shape and they're the same size, and therefore they would have the same measure. Therefore, 1, which kind of slid down to position for angle 5, angle 1 would be congruent to angle 5, and we could say the same for the other corresponding angles. Therefore, corresponding angles 1 and 5 are congruent, 2 and 6 are congruent, 3 and 7 are congruent, and 4 and 8 are congruent as well. So, what else can we state? Well, the opposite or the converse is true as well. So if two lines in a plane are cut by a transversal and the corresponding angles are congruent, well, then their lines would be parallel. Next, we're going to examine and develop a theorem about alternate exterior angles.
Okay, so because translations preserve size and it also preserves angle measures. So angles located in the same place but at different intersections have the same measurement. So that means that angle 1 is going to be equal to angle 5. They're going to be here. These two are the same angle right here. So this is going to be angle 5. Let's go ahead and skip to the next.
Use what you know about angle relationships to prove that alternate exterior angles are congruent.
Okay, so like explain theorems, definitions. So let's see. So if transversals, if a transversal if a transversal intersects, I'm just reading my my theories right here. So if a transversal intersects two parallel lines, then resulting in corresponding angles, and those are congruent, which are congruent. Okay. Let's see what else we got. You get all these different angles, which is just right there, the resulting in the corresponding angles. Okay. So let's see what we got here.
There are many correct ways to prove that alternate exterior angles are congruent. Let's look at one way. Use what you know about angle relationships to prove that alternate exterior angles are congruent.
Because vertical angles are congruent. So let's just go back up right here and look for our vertical angles, opposite sides. Those are all congruent. Angles 1 and 4 are congruent because corresponding angles are congruent. Angles 4 and 8 are congruent because angle 4 is congruent to both 1 and 8. Angle 1 is congruent to 8. What did you include in your response? Well, the vertical angles theorem, corresponding angles theorem, and let's see, what else do we have here? Let's see. I think those might be it.
Let's look at one way to prove that alternate exterior angles are congruent.
It's throwing me off because that extra ding in there.
Let's take a look at the alternate exterior angles theorem. Now, it states that if a transversal intersects two parallel lines, then the resulting alternate exterior angles are congruent. So, by looking at lines Q and S, which are parallel, cut by transversal R, then this states that our alternate exterior angles, such as angle 1 and angle 8, are congruent. We can also state then that angle 2 would be congruent to angle 7. We'll go ahead and take a look at proving the alternate exterior angles theorem. Let's go ahead and prove that alternate exterior angles are congruent. So in order to do that, let's start with what we were given. We're given that two lines A and B are parallel to each other. So let's go ahead and mark that on our diagram with
That's
arrows.
given.
Now I'm also given that line C is a transversal
right
of
here
lines
for
A
you
and B.
guys.
So line C down here is a transversal of lines A and B, forming these 8 numbered angles that I see. Okay, now in order to be able to prove our theorem,
5, 6,
I need to
7,
pick
8.
some alternate exterior angles. I'm picking angles 1 and 8. Now why do I know these are alternate exterior angles? Well, notice that angles 1 and 8 are on opposite sides of the transversal, a part of two different intersections, and they're outside of our two parallel lines. And because they're alternate exterior angles, if I can prove that these two angles are congruent to each other, well then I've proved that alternate exterior angles formed by two parallel lines cut by a transversal must be congruent. So let's go to our proof here. I need to start with what I'm given. I'm given that lines A and B are parallel to each other. So let's state that that's given. What else am I given? Well, I'm given that C is a transversal of A and B. Okay, well that gets me starting, but how do I prove angle 1 is congruent to angle 8? Well, what if we start with angle 1? Now I know that when two parallel lines are cut by a transversal, the resulting corresponding angles are congruent to each other. And I see that angle 1 and angle 3 are corresponding angles. So by that corresponding angles theorem, then I know that angle 1 must be congruent to angle 3. All right, well that gets me closer to angle 8, but it's not there yet. Look at angles 3 and 8. Do we know what kind of angles those are? I know they're opposite angles formed by two intersecting lines. That's right, they're vertical angles. So by the definition of vertical angles, we can state that angles 3 and 8 are vertical angles. And what do we know about vertical angles? Yes, angles 3 and 8 would have to be congruent to each other because vertical angles are congruent. So that means I can draw another arc right here. And since all three of these have the same arc, all three of these angles are congruent to each other. All right, well, what can I say then? Well, if A is congruent to B and B is congruent to C, then I know that A must be congruent to C. That's the transitive property. So if angle 1 is congruent to angle 3 by statement number 3, angle 3 is congruent to angle 8 by statement number 5, well then angle 1 must be congruent to angle 8 by that transitive property. So what did we do? Well, we proved the alternate exterior angles congruent theorem, if you want to call it that. It states that if a transversal intersects two parallel lines, then the resulting alternate exterior angles are congruent. Now, the converse of that theorem is also true. That means that if two lines in a plane are cut by a transversal and the alternate exterior angles are congruent, well then two lines would be parallel. Now here we have the alternate interior angles theorem. And this theorem specifically states that if a transversal intersects two parallel lines, then the resulting alternate interior angles are congruent. Here in our diagram, we see that lines X and Y are parallel because they're marked with the arrows. And since they are cut by transversal W, then the alternate interior angles that are formed, angles 4 and 5, would be congruent, and angles 3 and angles 6 would also be congruent. So now, let's go ahead and prove the alternate interior angles theorem.
Prove that alternate interior angles are congruent.
Okay, given X and Y are parallel, W is a transversal of X and Y, prove that 4 is congruent to angle 5, angle 4 is congruent to angle 5. Okay, so those are the givens. Start with the givens. So angle 4 and 1 are vertical angles, right? Those are vertical angles because they're across from each other, right on the same intersection right here. So that's that. Now angle 1 and 5 are corresponding angles theorem. Okay, and now C, which is 4 and 5, that means that those are exterior. Definition of supplementary angles. Nope, transitives. Okay, so it's supplementary angle. Let's see where we did.
Find one angle in the diagram with which angle 4 and angle 5 have a proven relationship.
Oh, you can't add 4 and 5 together. I don't know why I picked that one, but those are going to be the ulterior.
The converse of the statement is also true. If two lines in a plane are cut by a transversal and the alternate interior angles are congruent, then the lines are parallel.
Here we have the same side interior angles theorem. And this states that if a transversal intersects two parallel lines, the resulting same side interior angles are supplementary. So looking at my diagram, I can notice the same side interior angles 3 and 5. Because they are supplementary, their measures will add up to 180 degrees. We could say the same thing about angle 4 and 6. So the measure of angle 4 plus the measure of angle 6 also will add up to 180 degrees. Now let's go ahead and prove the same side interior angles theorem. We're going to prove same side interior angles are supplementary. So let's look at our diagram here. In our diagram, we see that lines B and C are parallel to each other. That information was given to us. And since it was given, why don't we go ahead and put that into our proof statement. B is parallel to C. But I'm also shown that A is a transversal of B and C. Since that's given to us, I'm going to put that in my proof as well. And I'm going to use this information to prove what? To prove that same side interior angles, also called consecutive interior angles, are supplementary. So in order to do this, let's think of other angles that might be considered supplementary. Well, looking at my diagram, take a look at angle 1 and 3. That pair, like angles 2 and 4, I see are adjacent angles that form a straight line, and that tells me they are a linear pair. I know this because the definition of a linear pair tells me.
4.
Well, if that's the case, then I can actually use the linear pair postulate. Remember what it tells you? The linear pair postulate says that if two angles form a linear pair, then I know
I'm trying to use
they're
this pen, guys, but
supplementary.
it's kind of throwing me off.
All right, well,
I like
I've got some supplementary statements going on here, but what do I know about supplementary angles? Well, going back to my glossary, if I were to actually look up the definition of supplementary angles in the glossary, it tells me that I have the measures of the two angles would add up to 180 degrees. So now I've actually got some equations to work with. But notice that two of the angles in this equation are interior, angles 3 and 4, but measure angle 1, measure angle 2, I'm talking about angles outside. All right, well, if that's the case, then I need to do something with angles 5 and 6. Well, looking at angle 1 and 2, notice how they form corresponding angles with 5 and 6, respectively. Angle 1 and angle 5 are corresponding angles, and since I've already stated that line B and line C are parallel, then I know that those angles must be congruent to each other because of the corresponding angles theorem tells me. So angle 1 would have to be congruent to angle 5, and angle 2 would have to be congruent to angle 6. All right, well, if two angles are congruent to each other, that means their measures are equal. We know this because of the definition of congruent angles. All right, so if their measures are equal, I can go back and look at step 5 and see, hey, wait a minute. I bet I could substitute out my outside angles and bring in my interior angles. So let's use substitution property and replace the measure of angle 1 with the measure of angle 5, and we'll replace the measure of angle 2 with the measure of angle 6. So now I have the measure of angle 5 plus the measure of angle 3 is equal to 180 degrees, and the measure of angle 6 plus the measure of angle 4 is equal to 180 degrees. And since we have two angles that add up to 180 degrees, what do we know about them? We know they are supplementary. Once again, that same definition of supplementary angles helps us out. So I've now proven that same side interior angles are supplementary. In fact, we can also state based on this that same side exterior angles would be supplementary as well. But what's the official proof saying? Well, our theorem that we've now proven, it states that if two lines that are parallel are cut by a transversal, then the same side interior angles that are formed will be supplementary. The converse is also true. The converse tells us that if two lines in a plane are cut by a transversal, such that the same side interior angles are supplementary, well, then we know the original two lines in the plane that were intersected, those would be parallel. We've been working to answer the question, what angle relationships are formed when parallel lines are cut by a transversal? Now, in this last part, we worked to study proofs and theorems about the relationships of angles formed when two parallel lines are cut by a transversal. And the relationships are shown here in the table in front of us. And what we're going to do is we're going to use these theorems and these proofs in order to be able to help us solve for unknown angle measures in this next part.
We can apply the relationships that were proven in the last segment to determine missing angle measures.
If measurement of angle 2 is 115, let's see. Ooh. I'm going to annotate this because if the measurement of these two right here have to add together and equal 180 degrees. So 180 minus 115, because it's saying angle 2 is equal to 115. So then this would be 65. So that right there means that this part has to be 65 degrees because they have to equal 180 degrees.
Now let's examine a diagram in which there is more than one transversal.
Okay.
Let's take a look at applying angle pair relationships to help us find other measures. To do that, we're going to analyze this drawing on the right. So I want to examine it in careful detail. We're going to use the given angle, this 100-degree angle measure that we have in the upper right corner. And I want to use that measure to find other measures. Now I notice that 100-degree angle is a long transversal D. That's going to be important We see that D is a transversal of lines E and F, and E and F are parallel to each other. Now that 100-degree angle and angle 15 I see down here at the bottom, I know those are alternate exterior angles. So because of the alternate exterior angles theorem, I know that angle 15 would have to be 100 degrees. And because angles 15 and 14 are vertical angles, and vertical angles are congruent, I know that angle 14 is 100 degrees as well. I could make the same case about angle 11 and the original 100-degree angle, because those are vertical angles. So angle 11 is 100 degrees. Now take a look at the remaining angles on that transversal. I have angle 9, 12, 13, and 16. And I can see that they form a linear pair with one of the 100-degree angles I've identified. Now a linear pair means two angles that are going to be supplementary. So if they're supplementary, then I can take 180 degrees, subtract 100 degrees that I know, and I'm going to get 80 degrees left. Therefore, angle 9, angle 12, angle 13, and angle 16, they all have a measure of 80 degrees. Now you'll notice that this was just one pathway that I could have used to be able to find the measures of all of these specific angles. There are other methods because we've learned other proofs to help us out. But you might also notice that only the measures along transversal D have measures that I know, because along transversal C, I can't find them. Why not? Well, that's because C has to have at least one measure along its transversal in order to be able to use the theorems to find any others. Had C been parallel to D, I would have been able to.
Determine the measures of the two angles.
Measure 2. Okay. So that's going to be equal to 4. 4 and this one are the same. So I'm going to say that this is 8, right? Okay, so 2 and 4, this has to be, so the measurement of 2 has to be 75. The measurement of angle 1, which is going to be a supplementary angle from 75 to 180, the difference is 105 degrees. So that should be that.
Now let's look at an example where the angle measures are algebraic expressions.
So let's take a look at another problem where we can apply angle pair relationships. And this time for our diagram, we're going to identify the measure of angle 3. And we want to justify our answer, which means we want to make sure we give a really good reason of why that answer must be correct. Now, if I take a look at my diagram, I see I have lines S and T parallel to each other. Notice the markings of the arrows. And so I see that R is a transversal. And because that transversal cuts the lines in such a way that this angle, x plus 10 degrees, and 2x minus 30 degrees are both alternate exterior angles, then I know based on the alternate exterior angles theorem, they must be congruent. Therefore, they have the same measure. So I can take that x plus 10, and I can set it equal to the 2x minus 30. Well, let's use this information to help solve for x and find out what is the measure of that angle. All right, well, I can subtract x from both sides using the subtraction property of equality, and I can also add 30 to both sides using the addition property of equality, and I'm going to get an x value equal to 40. So with that 40, I can substitute it back in for x. I'm going to get 40 plus 10, which gives me 50 degrees over here on the left. And if I plug 40 in over here, well, 2 times 40 is 80, and 80 minus 30 is 50. So that gives me 50 degrees on this side as well. This is important because it justified that my work was correct. Well, now that I have a 50-degree angle on the left and a 50-degree angle on the right, how can I use it? Well, I see that angle 3 here and this 2x minus 30, they both are corresponding angles. And since their corresponding angles are congruent when two parallel lines are cut by a transversal, I know that their measures must be the same. So I know angle 3 must be 50 degrees. Now notice this was just one way to be able to solve this particular problem. For example, I could have taken this 50-degree angle that I found here, realized, hey, it makes a vertical angle with angle 3. So therefore, angle 3 must have 50 degrees measured as well.
Use the diagram to answer the questions.
Okay. Measurement of 3 is equal to 3x plus 4. And measurement of 5 is equal to 2x equals 11. 3 and 5 are interior, same side interior angles. The equation so I should be able to add those together to equal up those. I want to put them together because remember, you have to add these two. If you add these two, or these two, you're going to end up with 180 degrees. That's how you could solve for x. So the measurement of 5 has to equal how much degrees? Well, we got to do the math there. So I'm going to go ahead and annotate this right here, and I'm going to get my pen out. Okay, so if I have 3x plus 2x, that gives me 5x. If I have 4 plus 11, that gives me a positive 15. That's all equal to 180 degrees. So I'm going to take away 15. This gives me, oh, that's an ugly 15. That's 1. Let me redo that one because I do not need that line. Okay, so 180 minus 15. So that's going to give me 5. That's going to be 7, 6, 165. Okay, so 5x is equal to 165. Divide that by 5. Divide that by 5. That's going to go in 3 times, and you carry the 1, 5. So that's going to be what, 53? Is that correct? 30. 5 goes into 16 3 times. So that's going to be 33. X equals 33. Is that correct? So 33. Now we got to add in this 33 will be the measurement. This 33. So now we have to do 3 times 33, which will equal 99 plus 4 is 104. That's the measurement for this one. I just used that right there. So that's this. Okay, so we're looking for the measurement of 5. Okay, so I just have to put that in. So 2 times 33 is going to be 66 plus 11 is 55. Did we do that correctly? Let's find out. I think I'm gonna stop using this and use just pen and paper because it's kind of throwing me off right there. And so let's see. Our measurement of angle 5 is going to be 77. I don't know why I got 55 here. I did 2 times, I don't know what I did wrong here in the math, but it is going to be 77 because 2 times 33 is 66 plus 11 is 77. So we should be good on all those ones.
Relationships between angles formed by parallel lines cut by a transversal can help you find unknown measures.
Sorry guys, my writing is ugly and it's really messing me up there. So instead of using that pen, I'm gonna go ahead and just use my regular pen and paper. So I'll have that ready for the assignment here coming up in just a little bit. I got to do a Zoom meeting now in a few, but I'm gonna go ahead and let this download, and I will see you guys here in a little bit.